Hi, Mr. Mick here, reviewing some of the answers to the Python class final exam, at least the course number 505, Computer Science Games and Apps final exam. I've already went over the multiple choice questions in another video, so I'm going to review this section here, starting with tracing loops. Here goes, question number 1. We have some code I have to trace, and here we go. Okay, sum is equal to 0. We have a for loop. The loop variable I is starting at 1, and we execute this line of code here. We work from the right-hand side, and then we go left from right to left. Sum is currently 0, so plug a 0 in there. 0 plus 1 simplifies to 1, and that 1 gets assigned into the variable sum. So we cross out that 0 and make it a 1 on our scratch paper. We go back up to the top of the loop. We know that the variable I goes from 1 to 2, so we keep track of I over here. We're not at 6 yet, so we go through the loop again. This time as we go through the loop, the variable sum is equal to 1. 1 plus 1 is 2. The 2 plugs into sum, so we do that with our scratch work. We go back up to the top of the loop, and the variable I goes up to 3. We go through the loop again. The variable sum, 2 plus 1 is 3. The 3 plugs into sum, and I goes up to 4. This time, I'm not going to erase this here, you're just going to have to follow closely. The variable sum is 3. That 3 plus 1 is 4. That 4 plugs into sum. We go back up to the top of the loop. I bumps up to 5. This time sum is currently 4. 4 plus 1 is 5. The 5 plugs into sum. We go back up to the top of the loop, and because of the 6, Python stops, and I stops at 5. It does not hit the 6. You might want to circle that on your paper there to reflect that that's the final value stored in the variable I, and the final value of sum is 5. Circle that. And now that we're done with the loop, because the loop ended, this line of code executes. Print sum. Well, sum is currently storing 5, so that therefore the number 5 prints out, and that's why you should put a 5 over here for your answer. The output that gets printed is 5. Okay, let's do number 2. Now number 2, this 2 is the step amount for the variable I, so be careful. The first time through the loop, I is 10. It starts at 10. Sum plus equals I. You should know what the plus equal symbol does. It takes this 1, it adds it into the variable sum. But this next time around the top of the loop, the 10 goes up to 12 because of that 2. And this time, sum plus equals 1 causes sum to go up to 2. We added 1. The next time around the loop, we add 2 more to the variable I. It's up to 14. Now we go through the loop. We add 1 more to sum. We go back up to the top of the loop, and because of this 15, we do not go to 16. We stop at 14, and 3 is what prints here as your answer. In exercise 3 on this practice exam, sum is 0, I starts at 1, sum plus equals 3 the first time through the loop. We go up by 1 this time to 2. We go through the loop, sum plus equals 3, we add 3 to get 6. We go up to 2, we add 1 more to I bumps up to 3. We go through the loop, this goes up to 9, back up to the top of the loop, I is up to 4. We go through the loop, 3 more gets added to sum. And when we go up to the top of the loop, we see that this 5 is here, which means we stop at the 4, And therefore, we're done with the loop. We don't go through the loop again. And the value that prints for sum is 12. And exercise 4, 5, okay, check, check. I starts at 1, check. Minus equals 1. We go down 4 for sum. We go back up the top of the loop. I is 2. We go through the loop. We go down by 1 here for the variable sum. Go back up. I goes up to 3. Sum goes down to 2. I goes up to 4. Sum goes down to 1. This time at the top of the loop, we do not add 1 more to I. We stopped at this 4. And the current value of sum is 1. We do not execute this code anymore. And therefore we print sum, which is 1. In this code segment, very tricky is 1. Good, we've already recorded that. I starts at 1. Good. We go through the loop. 2 times very tricky. 2 times this 1 yields a 2. The 2 plugs in for very tricky. We go back up to the top of the loop. I goes up to 2. Be careful here. This time, very tricky is 2. That 2 times 2 is 4. We go back up to the top of the loop where I becomes 3. This time, very tricky is 4. 4 times 2 is 8. We go back up to the top of the loop, and because of this 4, we don't go any higher. The final value of I is 3, and the final value of very tricky, which prints, is 8. Check, 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 check. This is a while loop, not a for loop that we're used to from the other exercises. Let's be careful here. This is either true or false. Is I less than 8? Yes, 1 is less than 8. So because that's a true, we go through the loop. Okay, let's do this. Sum plus equals 2. Well, that means add 2 here. I plus equals 2. Okay, add 2. Go back up to the top of the loop. Is I less than 8? True. So we go through and iterate the while loop. Sum plus equals 2. I plus equals 2. Go back up to the top. 5 is currently less than 8, so that's still true. Sum plus equals 2. I plus equals 2. Go back up to the top. 7 is less than 8, so that's true. Sum plus equals 2. I plus equals 2. Go back up to the top. 9 is not less than 8. That is now false. Because of that falseness, we do not execute the body of the loop. Instead, we execute whatever code is down here, print sum, and sum is currently 8. Just for the record, I is 9, but that does not print out. Number 7, result is 1, exponent is 1. Okay, while exponent less than or equal to 3. Is that less than 3? Yes, it is. 1 is less than or equal to 3. Result star equals 2. That means take 2 and multiply it with result. 2 times 1 is 2. This plus equals means add 1 to exponent. Well, that means cross that out and make it a 2. Go back up to the top of the loop. Check the control expression to see whether it's true or false. Is exponent less than or equal to 3? Yes, it is. 2 is less than or equal to 3. So we go through the loop again. Result times equals 2, which means take 2 and multiply it with result. Becomes 4. Add 1 to exponent. Go back up to the top. Is 3 less than or equal to 3? That's true. So we multiply 2 with result. We add 1 to exponent. We go back up to the top. Is 4 less than or equal to 3? Nope, that's false. Because it's false, we don't do anything else except print result, which is 8. In exercise 8, assume the user inputs these values in this order. Okay, both of these variables are 0, okay. Okay, this is the not equal to symbol in Python. You should know that, we've used it all school year. So while num not equal to -1 is true, we should iterate the body of the loop. Is num not equal to -1? True. 0 is not equal to -1. So we execute this code. We work from the right-hand side here. Sum plus num. Sum plus num is 0 plus 0. So 0 plus 0 is 0. The 0 plugs in the sum. Technically, that 0 is overwritten with a 0. And now we execute this line of code. You should know what the input function does. It allows the user to type in a number. We're pretending that the user typed a 3 in. This int is just required to strip the imaginary double quotes off of that 3 so the 3 can plug into the variable num like that. Okay, so all of that happened and we're now back up to the top of the loop. And is 3 not equal to -1? True, because that's true. We go through the loop again. This time, sum plus num is 0 plus 3. That 3 plugs into sum. And now this line of code gives the user the chance to input another number. So let's pretend that he or she enters a 4. So 4 plugs in here. We go back up the top of the loop. 4 is not equal to -1, so we got a true. And if you can read through my sloppiness, sum plus num, 3 plus 4 is 7. 7 plugs into sum. This time the user types in a -1 here for num. And we go back up to the top. That's called a sentinel value. We studied this earlier in the school year. So we ask ourselves, is -1 not equal to -1? False. And we don't execute the body of the loop anymore, and we print sum, which is 7. Number 9, here are the user's inputs. It's split over this page, sorry about that. Okay, sum plus equals num. Well, we take num and add it to sum. 0 plus 0 is 0. This time the user enters a 5 for the first time. So the 5 plugs in here for num. We go back up to the top of the loop. We haven't hit a -1 yet here under num, so we go through it again. We take that 5 and we add it into sum. We ask the user to input another number, so they enter this 2 this time. The 2 gets added into that 5 for 7. The -2 gets added into the 7. Careful there with adding negatives. And then a -1 gets inputted. We go back up to the top of the loop where this control expression is false. We don't do anything else, but we print sum. Sum is now 5. Basically, if you add all these numbers except for the -1, the sentinel value, you get the answer, the sum. Just like up here, the 3 plus the 4 was 7. Exercise 10. Here are a bunch of numbers that get inputted. 0, 0 to start. Okay, while num greater than or equal to 0. Okay, this is greater than or equal to 0. So we do this line of code. The 9 is being entered into the computer and stored in the variable num. Okay, this if statement. If statements are reviewed from the first half of the school year. The percent symbol there is actually the modulus operator, known as mod. It's the remainder operator. We've studied this before. So whatever num is, in this case 9, 9 divided by 2 leaves a remainder of 1. That's how it works. 9 divided by 2. The remainder of that remainder is 1. So all of this simplifies to the number 1, and we're asking if 1 equals 0. False. So we don't do this. But we do go back up to the top of the loop. 9 is greater than 0. So we do all this again in the body of the loop. And this time, the next number that gets inputted by the user is a 7. Now basically this if statement is just a fancy way of saying, is num an even number? 9 was not an even number, so this was a false. 7 is not an even number, so this is false. And because it's false, we don't do whatever's indented as the body of the if statement.